Hello, everybody. Welcome back to Mr. G and a Blackboard. So this is kind of part two of our factoring series of videos. So in the last video, we talked about three things. We talked about the greatest common factor. We talked about factoring trinomials, quadratic trinomials when a, the leading coefficient, is equal to 1. And then we finished off with kind of this special case of a difference of perfect squares, or a difference of two squares as it's known. So today we're going to talk about something a little more not really too much harder, but just kind of has a little bit more set of steps to it. So let's go ahead and get started. So with example 1, again, in the last video, we talked about what if I have a quadratic where the leading coefficient is 1 and I want to write it as a product of two binomials, right? So for this example, if you notice right away, this leading coefficient is not 1, it's 3, right? If you recall in the last video, I said the first step whenever you're factoring is to always find a greatest common factor, right? So in this case, if I look at 3, 11, and negative 20, first of all, they don't all have an x, so there's no variable, and the numbers 3, 11, and negative 20 do not share any greatest common, or any common factor. In other words, I can't find a greatest common factor between all three of them, right? Sometimes you'd be able to find it between two of them, but not all three of them. Sometimes you will find them in all three, which we did a problem like that in the last video. But in this case, there is no greatest common factor. So how do I handle it when this leading coefficient, I can't get it to be 1? So here's what you're going to do. So this is called factoring by grouping. Okay, so if you hear the terms factoring by grouping, or by grouping, you're going to factor something, this is what they're referring to. So what I'm going to do is sort of with the same strategy of multiplying to the last number, adding to the middle number. I am going to use that same idea, but it's not going to be multiply to negative 20 and add to 11. It's actually going to be multiply to negative 60 and add to 11. So where in the world did I get those numbers? Well, if you look up here, if I take 3 and negative 20, the first and the last number, the leading coefficient and the constant number, if I multiply them, I get negative 60, and then the middle number is still 11, right? So the method for this is kind of weird if you're just kind of going through a problem with numbers, but if you actually represent everything with variables, it kind of makes sense where this comes from, but we're not going to get into that. So if you have a leading coefficient that's not 1, the first step is to multiply the first and the last number, and then you're going to do your table here, and you're going to find numbers that in this case multiply to negative 60 and add to 11. So again, you can think through those, kind of trial and error, find out what they are, and eventually, hopefully you'd see that it is 15 and negative 4, right? 15 times negative 4 is negative 60. 15 plus negative 4, in other words, 15 minus 4 is 11. Okay, so we're going to continue this problem on the next slide here, keeping that in view. So if my original problem, if my original problem started with 3x squared and ended with negative 20, I always have my students immediately write those down first. So I'm going to write an equal sign, kind of piggybacking off of the previous slide, and I'm going to write these down, and I always leave space in between here, because now what I'm going to do is I've taken the first term and the last term, and now I'm going to take these two factors I found and write them as such. Okay, so if you look at this, well, 15x minus 4x is 11x, right? So I actually did not change anything, I'm just changing how it looks, right? So one more thing before we move on here. You see how this is a negative sign, or a minus? That's going to give me some issues with the next step, and I'll explain why in a second. So the name of factoring by grouping comes from this step. I'm going to group the first two terms and the last two terms together. Now, if you look at what I just wrote, if this is equal to the previous statement, it better be that if I multiply and add all these up, I get the original problem, right? So let's check. 3x squared plus 15x. Okay, that's fine. 3x squared, 11x. Okay, let's see if I get 11x from this. 15x minus 4x is 11x. That works. But this is actually not negative 20. It's what? if I take this negative sign and I apply it to here, I get positive 20, which does not match this, right? So the issue is I had a negative sign in the middle here. I just kind of grouped these two last terms together, and now it messed up everything because this is not a negative 20 now. Now it's actually a positive 20, which is not what I had before. So to kind of avoid that problem, I'm going to go back and do a little rewriting here. So if I had the minus 4x and the minus 20, okay, I'm not actually going to just group them like I just did. I'm going to make this a plus, negative, and then group them, because now if you look, I have 15x minus 4x, we're good, that's 11x, 15x minus 20, right? Positive and a negative is a negative, so I keep the negative 20, and now it is the same as the original problem, so I haven't changed anything. Again, I've just changed how it looks. So the moral of that issue we ran into there is if you have, if you have a minus sign, right here in the middle, you want to make it a plus, negative, and then do your groupings here, okay? So let's keep going. So there's the grouping, and now because we learned about greatest common factor in the last problem, this next step should be very easy. I'm going to take find the greatest common factor of these two terms, which would be 3x, 3x, and then I'm left with x plus 5, and then now this is kind of interesting wording wise. I'm going to find the greatest common factor of these two numbers, but that greatest common factor is not technically a greatest common factor because it could be negative, right? So if I said the factor of two numbers was 4 and negative 4, and I said the greatest common factor, you would say positive 4 because 4 is bigger than negative 4, right? So the greatest common factor of 4 and 20 is 4, right? But I'm actually not going to take out 4. I'm going to take out negative 4, okay? And the reason for that is because I want to get these two guys to match. So that's kind of like a check step. I got x plus 5, I got x plus 5. I'm good because now I'm in a really good spot factoring wise to take out an x plus 5 that they share in common and factor that out itself. Okay, and then what I'm left with, let me underline this, is these two pieces that I was left over with. Okay, so I'll put that in a different color this time. So this guy came here, this guy came here. That's what I was left with, right? And if you think about the distributive property, that's exactly what I just used in reverse. This 3x had an x plus 5 with it. This negative 4 had an x plus 5 with it, excuse me. So I took it out of both of them, and put it out front, leaving me with the 3x and the minus 4 left over. And now if you look, if I multiply these two binomials, indeed I do get my original problem up here, right? So I have just factored a quadratic trinomial where the leading coefficient, this guy right here, was not 1, okay, by using factoring by grouping, okay? So if you need to recap that problem, I would encourage you to go back. We can actually do that real quick ourselves. So again, I realized the leading coefficient wasn't 1, so I couldn't just do the table like normal. I had to kind of slightly make a tweak to it and do the first number times the last number, write that down, find two numbers that multiply that number and add to the middle number. I went down here, I took the two factors and wrote them in the middle. I kept the first and last term from the original problem. And then I did my grouping here and here with that little note we talked about regarding the minus sign. Found the GCF of these two, took it out. Found the GCF of these two, took it out. And then factored out this common x plus 5, giving me my final result. Okay, so I know that that's a lot of steps. This process is a little more tedious than before. So again, if you need to recap that, you should go back and try that again yourself and see if you get the same answer. Okay, so we're going to keep going here with example 2. And for this one, we are going to, let's change it up a little bit and use an A. Let's see, plus 4. Okay, so first of all, what do you notice right away? I have 4 terms, right? We haven't done one like that. if you see a factoring problem that has 4 terms, there's a 99% chance that you are going to use factoring by grouping. Okay, so now if you go back to this problem, at what step did I have 4 terms? Right there, right? So if I have 4 terms here, it's actually a little bit quicker than this problem because I'm already at this step, right? There was no trinomial I had to find where 2 numbers multiply to something, add to something, right? No, we were already at this step where there's 4 terms. So I'm going to jump in right at this step, but with this problem. So what did we do last time? Well, first of all, I got to be careful because I have a minus in the middle. This minus doesn't matter so much. It's just that this minus we saw in the last one gave us some issues. So I'm just going to actually write it on a different line and just rewrite it as follows. Okay. So you should realize that plus negative is the same thing as just minus. Then I group the first and second terms, the third and the fourth terms. I factor out the GCF from the first two. And now I'm thinking ahead. I hope I get an A-1 over here, right? That was kind of our check step. So I'm going to take out, what do I need to take out from these two to get an A-1 here as well? And you should see that you need to take out a -1, right? Which again doesn't, or excuse me, not -1, but -4, right? Which again kind of goes against this wording as, quote, greatest common factor, because we're not, taking out a -4 is not greater than taking out a 4, even though they both share a 4, right? So you really just have to kind of think about, what do I need to get so that these two guys are repeated, or repetitions of each other, okay? So I got that repeat. I'm in a good spot. And now I factor out the A-1 that a squared and -4 are attached to. And those are the guys that I'm left with right here, right? So I saw I have to have an A-1 in common. I factored that out itself, and I'm left with a squared minus 4, okay? Now, this is an interesting problem. If you look at this, what is special about a squared minus 4? Think about the last video. That is a difference of perfect squares. So I actually have to do one last step. Again, if you need to review that, go back to the last video. And I know that the pattern is always the variable minus the square root of this number, the variable plus the square root of that number. So in other words, I'd have a-2 and a plus 2. And there we go. That is the prime, what's known as the prime factorization. I can't break these down any further. Okay, so there is our second factoring by grouping example. Again, this one started with 4 terms, so I was already kind of jumping right into the grouping part. Okay. All right, let's go on to our third and final problem. I'm actually going to start nice and clean. Example 3. So example 3, this is a good one. Okay. Whoa, what's going on here, right? I have x's, y's, I have 3 terms, but this variable over here is also squared. Okay, don't get intimidated by it. Think about what we've talked about. Think about the greatest common factor in particular and the factoring by grouping. That's what we're going to use for this one. Okay, so if you have a factoring problem, again, I can't cover every single case, but we can kind of use these strategies along the way to help us out and try some stuff out. So if I have a factoring problem that looks like this, where I have multiple variables, the first one squared and the last one squared, and there's 3 terms, right? I am going to use a combination of factoring by grouping and the greatest common factor, okay? Which actually we can just say the greatest common, or excuse me, factoring by grouping, because factoring by grouping involves using the greatest common factor. So let's just say we're going to use factoring by grouping. So here we go. Remember, factoring by grouping, I take the first number, which in this case is 1, right? Whoops. And this doesn't follow the problem we did in the previous video where the leading coefficient was 1, because we didn't have all this x, y stuff going on, right? So this is kind of a different type of problem than that. So I take 1 times -12. So we're going to say multiply to -12 And do you remember which number we add to? Should be adding to 4. Okay, so I'll give you a second to think about that, and you should see that it would be 6 times -2. There we go. Okay, 6 times -2 is -12. 6 plus -2 is +4. Okay, so now we are on the breaking down part of factoring by grouping. So I'm going to say equals. You take the first term and the last term, so x squared and -12y, leaving some space. -12y squared, excuse me. And now I take the 6 and the -2, but now I have an x, y, right? Which again, I didn't change the problem. 4xy is equal to 6xy minus 2xy. It's just that I had to find what were these two numbers that I need to use, which is where this table came into play. Okay. And now comes the grouping. Oh, got to be careful. We have this minus sign here. So I'm going to rewrite the problem. You don't have to rewrite the problem. I just like to keep it step by step here. Make it a plus -2xy minus 12y squared. Okay. Group the first two terms. Group the last two terms. The GCF of x squared and 6xy, this is where that skill comes in play, is just x. So you should get x plus 6y, right? Again, I'm looking for this guy to show up over here. So what do I need to take out of here? This is a, make that a little clear, this is a negative. What do I need to factor out of this term and this term to get x plus 6y? And you should see that it's a -2y. There we go. We got our x plus 6y repeated, right? Whoops. Okay. Which is a good sign. That's kind of our check step, we like to call it, right? So now my final answer, they have an x plus 6y in common. You don't have to write that first. You can write it second. X plus 6y, I take out, that's in common, and I was left with the x minus 2y. Okay, so this is the result of taking out the x plus 6y, and I was left with the x minus 2y. So in all, I have x plus 6y times x minus 2y. Okay, so there we go. We had our kind of final problem of factoring by grouping. That one was looked a little bit different just because we had some x's and y's going on there, but same general idea or strategy of factoring by grouping. Okay. So I'd really encourage you to go through, rewatch the video, try them on your own, find some other problems to practice with factoring by grouping. It's very easy to find problems on that. It is a little bit more tedious of a process the first couple times you do it, but once you do it a few times, you kind of get the hang of it. I hope this video was helpful, and thanks for watching, guys. Bye-bye.